Looking at queues today. There's a few different dynamics to queues. We have normal queues, priority queues, and circular queues. So we're mostly going to be looking at queues and priority queues today, and then you'll be looking at circular queues next week. Okay. So key things you need to be able to understand to do with queues is understand the use of queues as an ADT, which hopefully you remember stands for abstract data type. Identify the pros and cons of using queues, and also explain how to add, remove, and return data items from a queue. So that's the main key things that you need to know. So a queue is an example of an ADT. So remember, an abstract data type is essentially it's down to the programmer how they choose to program it and implement it. We just need to know that it works. Okay. So the way that programmers program them is essentially how they see fit, but they do need to follow the rules of a queue if they want to consider it as a queue data structure. So one of the key rules is that it's a FIFO, which is first in, first out structure. So what does that actually mean? If you think about queuing for a bus, we know we love the Great British queuing system. The first person at the front of the queue should be the first person on the bus, unless you've been to London, and then there are no rules. But most other parts of the country, if we wait in a queue for something, the person that arrived first and was in the queue first will be able to move on to the bus. Okay, so they are at the head of the queue, and then if anyone else wants to join, they go to the back of the queue, and they are then at the rear of the queue. So the first item added to the queue is the first one that therefore gets removed in programming terms as well. And if an item wanted to join the queue, it needs to go to the back. It can't go to the front and take the space of the person that just left. The term we use for this is to on queue. Okay, and if an item needs to be removed, it needs to be removed from the front of the queue, and that's when we dequeue an item, so we remove it from that queue. We can also peek the first item just to see what's next in line without actually returning and removing the value. So looking at this as an example, we're going to use just a standard kind of array/list concept here. So I'm going to be doing some programming in lists in the next video, but you can use an array also. But looking at this concept here, we know that we have our index positions, and there are a number of people already in this queue for the bus. Okay, Fred was the first to join, followed by George, James, and Sophie. So the front pointer, and this is where it's really quite important, front and rear pointers essentially tell the program where the front and the end of this queue is. So the front pointer will always point to the first item that was inserted when it's first instantiated, and the rear pointer points to the last. So there's 4 items at the moment. Let's say Alicia comes along and decides to join the queue. Where does the rear pointer go now? Hopefully you realise that the rear pointer now moves, and it indicates that Alicia is the final item in the queue. What if Fred now gets on the bus? So he's left the queue. What happens next? What will happen to the front pointer? Well, George is now at the front, and this is a really important point about queues. What you can't do is just move all of the indexes up. A slightly better analogy might be to think about the fact that if you were to have to take a ticket at a waiting, you get them in lots of places. Doctor surgeries now have started doing them again. You take a ticket. If I take ticket number 1 and someone takes ticket number 2, after I've been called in to see the doctor, ticket 1 and 2 are no longer reusable. They will just go in the bin. And at the next day, they'll probably restart the counter back from 1, and so on it goes. Think about that in your concept, in the fact that you can't just move everything to replace this. So, question, what if I now want to let Samson join the queue? Now, if we're using an array and there are no more spaces and I can't use this one, what do we do? Have a little think about that for a second. Okay, so as I said, cannot use that first place. All items must be added to the end. Remember, that was one of my keys. And so we're at the first limitation of a queue. You might be thinking, well, then why are we using them? But there are lots and lots of reasons why we will. This is just a simple way of understanding some of the limitations. So the first problem is that if I only have 100 places, once those 100 places have been taken, as I begin to remove items from the front of the queue, I can't then add items back into those positions. So if I go to add an item, there is already something in the index position 99 in my 100 place array. I can't now add anything. But that's where we use circular queues, and we will talk about those in a later video. Obviously, if this was Python, you might be thinking, well, I can just use a list and it will go on forever, memory depending. However, in reality, most languages don't support lists, and so it would be done using an array. And so we'd have to declare the size of the queue at the start when it is instantiated. So why use it? You may already be thinking, I don't really get this, okay? There are loads and loads of real life scenarios, but essentially there are many uses to a queue, and in reality queues are created to hold very large numbers of data of items. You wouldn't just have a queue for 5. So uses of a queue structure include things such as serving requests on a single shared resource like a printer, CPU task scheduling. So you'll know with a printer it is a first come, first serve basis. So if all 20 of us send something to the printer right now, then as the jobs are received, they will be printed directly in that order. If one of you decides to suddenly print something and 10 other people are in front of you, it won't prioritise that. It will just put you at the back of the queue and it will get to you when it is done everything that was in front. And a lot of printers, by the way, are like reset. So the ones at school reset every 24 hours. So if there were, say, 2,000 places in the queue, as an example, and towards the end of the day, you might think, well, there's probably 2,000 things printed. Well, it's completely reset and it will start again from the beginning. Also CPU, task scheduling, etc. So dealing with requests as they're received, so deciding how to allocate up. Well, actually, well, this was received first, I'm going to do this task and I will get to that when it's done. Think about opening files. You won't move on to the next file download until it has got enough memory, because the other one was there first. It was already in the queue and already been dealt with. Call centres use them, so holding people in line and waiting until the next person is free. That will all be done using the computer system, and also things like handling of interrupts in real-time systems. So again, it's very much first come, first serve. So they're just some examples of where it is used in computing. We see it used in life all the time, but actually it is used in computing as well. So priority queues. Now, obviously, you heard me talk about when we mentioned things such as sending the items to the printer, and I said, well, it won't move up the queue, it wouldn't be considered a priority. However, there are examples where lots and lots of examples where you actually want something to be a priority. Now, to take this really basic, think about with an A&E triage. Hopefully, not too many times, but most of us have generally been to A&E once or twice. We go in to see the triage nurse, and then we sit there in a waiting room for 4 to 6 hours. Now, what you'll know is the longer you're sat there, the more you start to realise that some people come in after you and then get seen before you and seem to go off into the doctor. Well, why is that? Well, the A&E, the triage, have a priority system, a scaling system that states how quickly you need to be added to that list. And so instead of having a strict FIFO, first in, first out structure, while they might have that, the placement into the queue can be changed. So if there are 10 people in the queue and the first 3 are considered to be category 1, which is the most severe, the rest are category 2, and then an 11th person comes along that is a category 1, they would be inserted into the queue after those first 3 into position 4. Everyone else would be moved down the queue. Hopefully you're already starting to see how this would work in a programmatic sense. You are just essentially moving and updating the location of each item within the array in accordance to this priority system. So it allows you to declare a status and essentially say, well, what priority will that be given? So a couple of things that you just need to start going away and doing some research. So enqueuing the item, think about in this logically. First thing I always need to do before I try and add an item is there memory available? Now I've put list here, that's because I was programming a list, but actually is there spaces in the array, is there memory in general? And if there's not, then you need to send an error message because you can't add anything to it. So by send an error message, what I mean is not that you let it crash, but you pre-design your code to make sure that you have done that check and let the person or the user know, I'm sorry, you can't add anything to this list. The list is currently full, or you can't add anything to the queue. Because if you don't do that, if you don't make that check and it is indeed full, it will crash. And obviously you want to always avoid doing that. So you want to make sure that you've thought about this. However, if there's memory or there's space in your queue, then you do proceed. you're going to create a new node to hold the data, and then you're going to update the back pointer so that it now points to this new node, and you now know where the back of your queue is. Dequeuing an item. So first thing first, so remember dequeuing is to remove it. Check if there are any current nodes in the queue. So essentially, you cannot remove something from a queue if there is nothing in the queue in the first place. So if you say, give me the current item and there is nothing there, it will crash. And so you need to run that check, just as I said before, output an error message. Sorry, user, but unfortunately there is actually nothing in your queue, else you can proceed, okay? So how you do that, you need to return the data that is found at the location of the front pointer. The front pointer should tell you where your first item is. Update the front pointer now to the next item in the queue. Pretty straightforward. So the task that I'm going to get you guys to do for this lesson is going to be complete the worksheet that I'm going to upload for you onto Teams, and also create your own set of revision notes and submit these via Teams as well. What we're going to be moving on to next week is programming programming queues. But first, we're going to look at circular queues, and then you're going to have, I think you've got 2 lessons next week, so and obviously some personal study time. You will have to potentially write the pseudocode in the exam, but you definitely will have to compare data structures and understand the pros and cons for them. So one of the things that you need to do in your revision notes is actually cover what the main advantages and disadvantages are. Okay.